This is our third video on the dot or scalar product. For taking the dot product of two vectors in unit vector form, for example, when taking A dot B, where A is AX times I hat plus AYJ hat, and vector B is BX I hat plus BYJ hat, we FOIL our terms like you learned in math, just like we do when multiplying polynomials. Recall that I hat and j hat are unit vectors that point in the x direction and in the y direction. A unit vector is a vector of length 1, and the I hat or j hat value, or if we have the z-axis, it's k hat, simply tell you the direction that that component is pointing. So here we have two vectors, each of which has some x component and some y component. That's what we're saying here in this second line. Let's ask this though. Why is the net result when we do this, why is it just ax bx plus ay by? In other words, we are supposed to FOIL these terms, and you remember in math that when you FOIL things, you go first, outside, inside, and then last FOIL. Well, two of those products disappear. These two, AXBY and AYBX, they disappear. Why is that? And they disappear because when you take the dot product of any two perpendicular vectors, you get 0. So when you take the x component of vector A multiplied by the y component of vector B, that becomes 0. Similarly with AY times BX. Whenever you're doing the dot product of two vectors, you simply multiply their first components, their second components, and so on. So let's practice that. Suppose we have a force here, and it's directed not entirely in the x direction, nor entirely in the y direction, nor entirely in the z direction. It's directed at some odd angle relative to all three of those axes. And here's the displacement that is undergone. What would be the work done with this force and this displacement? Work is the dot product of force and displacement. I could put a D here. If I want to put S, I can do that. Sometimes S is used for displacement. So what we want to do is take the I hat components for both of these multiplied together, then the j hats, then the k hats. Something like this. 3 times 2, there are the I hats, and then the j hats are 2 times 7, and then the k hats are 1 times 5. Now they're all positive here, so that's kind of nice. There, the j hats go together, and the k hats are multiplied together. So what does that give us? 6, 14, 5. How much is that? 25. And the fact that it's positive, we learned quite a while ago that whenever positive work is done, the speed of something is going to be increasing. That's how you take the dot product if you have two vectors in unit vector form.